Hello and welcome to Water Quality. In this video, I'll go over how to solve the pH of a weak acid solution where the weak acid, in this case acetate or acetic acid, is added as a base. So in a previous video, I showed how to solve the pH when the weak acid is added as an acid, and now I'll show how to do this when the weak acid is added as a base. So our base is sodium acetate, and 10 to the minus 3 moles are being added to a liter of DI water, and we want to solve the pH. The first thing I'm going to do in this problem, and that what I do in similar problems, is to write out all of the reactions. And so in this case, the first reaction I'll write out is for acetic acid, and I'm abbreviating acetic acid because it has a fairly long formula as HAC, and it's a weak acid, and so what that means is that it's not going to completely dissociate in water, but we'll have some of the acid and the base present. So acetic acid dissociates and donates a proton, and acetate is formed. So you have both the acid form and the base form of acetic acid in this solution, and the partitioning of those two species is described using an equilibrium constant, and we call it K and put a subscript A to donate or to show that it's an acid, and this value is 10 to the minus 4.7. So it has a pKa value of 4.7. Now I also need to show the dissociation of sodium acetate. So when sodium acetate is added to water, it completely dissociates. And the reason it does that is because the solubility limit of sodium is really high, and we're dealing with natural waters where we won't have sodium in such a high concentration that it's going to not dissolve. So in 10 to the minus 3 moles, it will completely dissolve. And so we can write 100% ionization. The last reaction that I need to add is for water. Water is also a weak acid because it can dissociate in water, but not completely. And this reaction is described by the equilibrium constant K sub W and has a value of 10 to the minus 14. The next step I'm going to take in solving this problem is to write out the mass balance equation. And we call this a C sub T AC, so it's the total concentration of acetates. It's basically all the places that acetate can be in the solution. So it includes the acetic acid and also the acetate. And the concentration of this is going to be what we added to the solution, which is 10 to the minus 3 moles per liter. So just because we added 10 to the minus 3 moles per liter of acetate doesn't mean it's going to stay as acetate. Some will go over to acetic acid. And at this point, I also like to identify the sodium concentration, which is equal to the CTAC in this case because they have a 1-to-1 ratio. So that will also be 10 to the minus 3. The next step is to write out the charge balance. We're using an analytical solution here. So I write all the positive species on the left. I have sodium, hydrogen ion, and then on the negative side I have hydroxide and acetate. So I'll make some substitutions here. For the hydroxide, this is K sub W over H plus. And then the acetate, I'll substitute in alpha 1 times CT. Then I have the hydrogen ion and sodium. In the next step, I'm still going to keep this as KW over H plus, but I'll write out the alpha equation. And just as a reminder, this is a monoprotic acid because acetic acid only donates a single proton. So I'm going to use alpha 1 and I'll use the monoprotic alpha. And so this is Ka over Ka plus H plus times Ct acetate. And this is H plus, and I'll substitute in Ct AC here. Okay, so in the next line, I'll make the substitutions. And so 10 to the minus 3 for the Ct AC, 10 to the minus 14 for the Kw. Ka is 10 to the minus 4.7. And then my Ct, 10 to the minus 3. Okay, so to solve this, I use the solver function on my calculator. I also have an R code and a MATLAB code, an Excel spreadsheet, so you can use whatever you want to solve this. And the answer that I get is 1.40 times 10 to the minus 8 moles. And if I take the log 10 of that value, I get it in the 10x form. So this is 10 to the minus 7.88 moles per liter. Oh, sorry, the 7.85 moles per liter. So that gives me a pH of 7.85, which is the resulting pH when I add 10 to the minus 3 moles of sodium acetate to a liter of DI water.